In this lesson, we're going to talk about transformations on logarithmic graphs. The good news is that these transformations are exactly the same as all the transformations that we've done in the past. So again, we have an a value and a k value. Those represent our vertical movement. So this is a vertical reflection or stretch, and this is up and down or vertical shift, and our b value will be a horizontal reflection and or stretch, and the h value will go right, left. So all of these work exactly the same. Your horizontal movements always do the opposite. So the biggest thing here is just going to be remembering how to graph the logarithmic functions, which are going to be your base graph, and then you're just going to do the transformations from there. So in this example, our base graph, the starting graph, would be log base 10 of x. And from there, you would have a vertical stretch by a factor of a quarter, a horizontal stretch by 1/3, to the left 2, and down 7. If we look at example 2, the first one here, we have log base 3 of x. So remember the points for log base 3 of x would be 1, 0, 3, 1. And now we're just going to the right by 1. So really you don't have to lay out the points. All of these points are just moving to the right by 1. The thing to note is that the asymptote, the vertical asymptote, shifts to x equals 1. So it also shifts to the right. So with our exponential graphs in our previous lesson, our asymptote only moved when we moved the graph up or down. Now, the asymptote will move when we move the graph left or right. So if we look at the next one here, the first base graph is log base 10 of x. Remember, if there's no base there, it's automatically a base 10 plus 2. So that means we're moving up 2. So I've drawn 1, 0, 10, 1. And then I've just moved these up 2 and up 2. Again, for some reason, I've missed drawing in a lot of vertical asymptotes. So please make sure you add those to your notes. Here, the vertical asymptote did not move at all. So it asks you for the domain, range, asymptotes, and intercepts. So here, your domain would be that x is greater than 1. Your range would be YER. Your vertical asymptote is at x equals 1, and your intercept is at 2, 0. And that's your x-intercept. Over here, again, your domain would be x is greater than 0. I guess I should also include or 0 to infinity if you prefer that notation. Your range is YER, or negative infinity to infinity. Your vertical asymptote is at x equals 0. It has not moved from the original. And the intercept here, do we know? Can we calculate that? Actually, you know what? You do not yet know how to calculate that, so don't worry about it. In a few lessons, we will go over how to calculate that. So don't worry, I won't ask you for this quite yet. Basically, we would be plugging in when y is equal to 0, and we'll go through that at a later point. We'll save that for another day. Okay, you'll notice on these ones that I have included the table of values, which can be helpful when you have sort of more complex or more complicated transformations. So for this first one here, we have log base 10 of 2x plus 3. The key thing to remember, just like always, is we need to factor out the b value. So right above here, I've written the expression with the b value factored out. So this means I have a horizontal stretch by 1/2. There we go, by 1/2. And I'm going to the left by 3/2. So what I've done is my x, y values, 1, 0, and 10, 1, are going to become 1/2 x minus 3/2, and the y value remains unchanged. What you'll notice is on these graphs, I didn't actually graph log base 10 of x. I didn't graph the original, and that's because you really don't have to. Once you're feeling comfortable with the base graph, you don't always have to draw it. If you prefer to go point by point, that works. So here, these points will shift. We have 1 times 1/2, which is 1/2 minus 3/2, so -1, and 1/2 times 10 minus 3/2, which is 3.5. So just do your best to draw that as approximately as you can. And what you'll see here is we've got our domain is x cannot equal -3/2. If you want to write that in the other notation, remember you would write -infinity, sorry, not -infinity. Yeah, this I should be writing. X has to be greater than -3/2, sorry. And then here we would have -3/2 to infinity. YER, and your intercept is at -1, 0. If we look at the next one here, we've got, again, log base 2, -x minus 1. You need to factor out the b value. So in this case, the b value is -1, or is a horizontal reflection, and you're moving this graph to the left by 1. So again, I chose not to draw the base graph. The base graph would be log base 2 of x. So that is the point 1, 0 and 2, 1. But I need to change the sign and move it to the left by 1. So here was 1, it's going to become -1, and then to the left will become -2, 0. And here, change the sign and then move it to the left will become -3, 1. So here's my graph. Notice the asymptote also moved over. I should have mentioned that on this one too. The asymptote now, the vertical asymptote, was at x equals -3/2. And this vertical asymptote is at x equals -1, because it also shifts to the left. There's no y-intercept because it's not going to touch the y-axis. Your x-intercept is -2, 0. And your domain, I don't know what I was doing when I did this, is x has to be less than -1. If we look below, I have some exponential graphs. This was just to include e. So these are kind of a flashback to what we were doing when we were learning about e, just incorporated some now. So these are exponential graphs. So you're going to begin by graphing y equals e to the x, and then you have a vertical reflection and a horizontal reflection. So both x and y are going to change signs. So my graph of e to the x has the point 0, 1, 1, 2.718. And I'm just going to change the sign of both x and y values. So you can see here that this reflects vertically and horizontally. Again, this has an asymptote of y equals 0 because this is exponential, not logarithmic, and that asymptote does not move when you change the signs of x and y. If you look at the next one, we have an absolute value of an exponential function and moving down 1. So here I graphed e to the power of x and moved it down 1. So this is a little bit tricky to see. So this graph here is y equals e to the x. That's the gray graph. I moved it down 1, and then I took the absolute value. So when you move it down 1, your asymptote moves to y equals negative 1. But then when you take the absolute value, anything that's under the y-axis reflects upward. So the asymptote moves from negative 1 up to positive 1, and this little tail of the graph reflects over the line. So this is a funny looking graph. You're not going to see very many of those, but it is kind of a neat culmination of all the different things that we've done in terms of transformations. And finally, on the next page, related to what we just did, we just looked at the graph of e to the power of x. So now we're going to look at the graph of ln, or natural logarithm, or remember, that's log base e of x. So here, remember my points, this is a horizontal reflection. The point xy on the graph of ln of x is 1, 0, 2.7181, and that's going to become negative xy. So negative 1, 0, negative 2.7181, and that's what I've drawn here. And then finally, over here, sorry, I failed to mention, the asymptote is at x equals 0, and the intercept is at negative 1, 0. And over here, we have the graph of ln of x, and we have a vertical reflection, movement to the left by 2, and up 1. So here, the x value is going left 2, vertical reflection changes the sign of y, and we're going up 1. So 1 take away 2 is negative 1, and 0 plus 1 is 1. 2.718 take away 2 is 0.718. 1, change the sign to negative 1, plus 1 is 0. And here, because we have a movement left and right, our asymptote is also going to move from x equals 0 to x equals negative 2. You can see I've drawn that here. And again, our asymptote is at x equals negative 2, and our x-intercept is at 0.7180. So, key things to remember from this lesson are that we have exponential functions. These will look like this, or like this. These have the point 0, 1, and 1, whatever the base is, and have an asymptote at y equals 0. Logarithmic functions, I should draw that differently, are going to look like this, or like this. And they're going to have the points 1, 0, whatever the base is, 1, and an asymptote at x equals 0. So those are the two types of graphs we're working with. It's really important that you know the base graphs and then do the appropriate transformations.